Welcome back to another installment of Text Processing and Analysis with Python. LING 360. We're going to be looking at lesson 4.1 about functions, defining your own function today. So let me share my screen and let's get cracking. All right, so the objective of this lesson is that students will define their own functions, often referred to as user-defined functions. That is, the user of Python, the end user like us, we define our own function. So chapter 3 of the book, textbook, talks about this idea. And it first talks about the fact that we have seen functions up to this point, right? We've seen handful of functions. We've seen type. The very first lesson, I think it was, we looked at type. So you can see what data type a value has, right? So type 42 would be int, class, so we return that. We saw int, where you can force a string. For example, this string, you can see it's a string because there are quotes around that 32, right? That's a quote and that's a quote. So this would force it to an int, that's an integer, that does not have strings, that does not have quotes around it. If you tried that with something that can't be coerced, that is forced into an actual integer, it would return an error, return a value error. Okay, you can do this on floats, that is numbers with decimal points, and it'll just chop off the decimal point. So if you give it 3.99999, it'll just give you 3. If you get negative 2.3, it'll just give you negative 2. If you use int. Floats, if you give it an integer, it'll give it a decimal point of just 0. Anyway, we've seen string as well. If you give it an integer, it'll return a string. You can tell it's a string because of those quotes around it, right? And we've seen print as well a lot. We've seen the input function to get input from the user of your script. Okay. So let's take a look at some examples here. And I will point out in Python that the colon and the indentation are important. They're not just extra niceties for the human trying to read your function. You have to do it for it to work. Let me just grab this little function here. I'm going to copy it off my lesson plan, jump over to PyCharm, and take a look at it over here. So the first line 1 here, let me make this a little bigger for us. Line 1 is what's called the head of the function. It starts with a keyword, a special keyword that is def for define a function. And then the next part is the function name that you want to give it. So I chose to give it uppercase _ vowels. And then you have parentheses, and you often have something you pass into the function, some value or list or something that you pass in the function that the function works with. And then closing parentheses and a colon, okay? And then line 2 here on my script is what's called a doc string. A doc string is a way to tell the user of your function what the function does. It's just a quick one sentence. It can be more than one sentence. And just tell the user what it does. So I say takes as input a string and returns as output a string with the vowels converted to uppercase, right? So that's why I named this function very transparently. Okay, so then I define the function here. This is the body of the function. I guess the last, this is the body from lines 3 to 10 is the body of the function. And then line 10, the last line here, says return. It's a special keyword, return, and then whatever I want to return back out. So let's just look through the logic real quick. Line 3, I create a variable that has an empty string. Those are 2 double quotes without anything between them. And then I loop over every character in the input string that came in through the function call, right there. And I'm going to a for loop on line 4 here. And I decided to give it the variable name character. And then we're going to loop over each character in the input string. And we say if the current character is in this string, meaning it's one of those lowercase orthographic vowels, then I want to concatenate with that output string that initially has nothing, right? I want to concatenate with it, or concatenate onto it on the right side of it, an uppercase version of the current character. Okay. And And then, right, so this, oh, sorry, this is simply just to point out that this, once again, this is a shorthand. This is shorthand for this line 7, which I've commented out. Right, so this means take whatever you have as the value of output string and concatenate on the right side of it an uppercase version of the current character, and then save that back to itself. That is, save it to output string again. So we're just building up an output string. Okay, so if we find a val, push it to uppercase and put it on this output string thing. Otherwise, meaning if it's not one of those 5 orthographic lowercase vowels, then just push on the character to this output string. And once you've gone through all the characters in the input string, then just return out the output string. Right, so let's give this a try. So the thing here is when you define a function, you're only defining it. You're not actually calling anything, right? So to call it, you have to, let me make this a little bit smaller. You have to call it. So I need to call it down here and say uppercase vowels and give it some string. Hello, good morning. Okay, that's good. Now, when I run the script, it's going to run it, but it's not going to tell me about it, right? Because I'm not asking it to print it out. Just to show that, I'm going to run the script. Keyboard shortcut, enter. And down here, it didn't print out anything about hello, good morning, right? See, it says it ran this thing using this version of Python. Anyway, it didn't print anything to me, right? Once again, you have to print things out when you're working in script mode, when you're running the script. There we go. There's the output that we wanted to get, right? And all the vowels are uppercase. And the H is uppercase because it was already uppercase when I passed it into the function. The O is uppercase now, the 2 O's in good, etc. Okay. So once again, what we've seen here is you have to start a function definition with def. You give it a function name that you want to give it, and then open close parentheses with possibly some argument or arguments passed in, colon, and then everything is indented in the body of the function. And you do something with the input you get, or you don't have to. You can have a function that doesn't require any input from the user, just does something. But anyway, the most useful functions actually do something with the input from the user. Okay. This is called a doc string again, where you just give a quick summary of what the function does. And then you need a return statement at the end of the function to actually return back out to this point in the script. So what it's doing is lines 1 through 10 here are just simply defining the function. Unknown caller. Line 12 calls it. Let me turn off my phone, sorry about that. Line 12 calls it. And so what it does is it takes this string that's right here on line 12, hello, good morning, and it comes up into the function and runs this code and returns this line 10, returns it back out to this point on line 12. So it's kind of interesting. You define a function, you come down to line 12, you call it, it takes the input string on line 12 and goes back up and runs the function and gets the output and returns it back to line 12. And then this print statement just prints it out to us so we can see it. Okay. So if you want to stop the video and analyze that or try to make it work on your end, you should do so now. Okay, let's take a look at another function. Here is another one, another example. All right, so this is dash vowels. Again, we have def, name of the function I gave it, open parentheses, some argument. It's a variable name that I will use down here, right? This variable name can be any well-formed variable name, colon, and then everything else is indented, one indentation below in the body of the function there. And we have a doc string here that tells the user what this does, takes as input a string, returns as output a string with vowels replaced with dashes. It's the same idea of what we just saw. Basically, I'll go ahead and call it down here. I'm going to print the result. I'm going to call it here dash vowels. I'll just go and do the same thing. Hello, good morning. I'm going to run it, keyboard shortcut, enter. And down here on the output in the console, you can see hello, good morning with all the vowels, lowercase vowels dashed out. Okay. This is pretty much the same thing we just did, same logic. We have a for loop, and we look at and see if the current character is one of these 5 characters. If so, slap on a dash on the right side of this output string. If not, just slap on whatever character you have there. And then once you're done with all the characters, then return it out. So I just want to point out again that indentation is highly important in Python. And the fact that this return statement is lined up that has the same level of indentation on line 9 as the for loop on line 4 means that this for loop will finish. It'll finish all the characters, and then this line will run, right? All right. So if you'd like to pause the video and look at that for a minute, go ahead. Okay, well, that is a quick rundown of how to make functions, define your own function in Python. Let's go ahead, try some practice. It says define a function that takes as input 2 strings and returns as output a Boolean value that is true or false, indicating whether the 2 strings are anagrams of each other. That is, the letters of one word can be reordered to spell the other word, like with secure and rescue, right? So secure is an anagram of rescue because you can reorder the letters of secure to create the word rescue, right? You just move the S to the middle there. Anyway, you can see that, yeah, those 6 letters are the same between these 2 words, right? Now, here's some hints. I give 3 hints. Sorted list name or list name.sort will be your friend here, meaning you're going to need to sort. You're going to need to take 2 strings as input, sort them both, and see if those 2 sorted strings or lists are identical. And that's pretty much what an anagram is, right? Number 2, you should not ask the user for 2 strings with input. Rather, you should include 2 arguments in your function, one for each word. So you have like word 1 and word 2 as arguments in the parentheses of your function head, right? Your function definition head. And then hint 3, be sure to account for possible differences in capitalization, right? Here I just have everything lowercase, but you should deal with the possibility that the user of your function will give one word as uppercase or have one uppercase letter in the word, and the other word has all lowercase. You need to deal with capitalization, is what I'm trying to say there. Okay. Here's a bonus. If you want to try it, don't go for it. If you can't figure this out, don't worry about it. Modify your function so that it throws an error if the user doesn't supply 2 strings as arguments to the function call, and or if the user doesn't supply values of type string. Okay, if that's out of your wheelhouse right now, don't worry about this bonus thing. Okay, so let's take some time here, take a few minutes or more, upward of 10, 15 minutes if you need to try and make a function like this that does this. All right, ready, set, go. Pause. Okay, welcome back. I hope you gave it a good faith effort because this is a cool function and it really brings together a lot of things we've seen. So I hope you gave it a good faith effort. And here we go. Let's take a look at how I would approach this. I'll jump back over to PyCharm. And let me get all of this. This is from my solution file that you have access to on the CMS. Okay, so this, all right, this is describing what I asked you to do. So line 3, make this a little bit bigger. Line 3, I don't know why I had squiggly lines. It's doing like spell checking or something. Don't worry about the squiggly lines below the lines. Line 3, we have def for define, right? The keyword that says here is a function definition I'm going to give you. I decided to call it is underscore anagram. Then I have 2 arguments passed in to the within parentheses, right? I have WD1, word 1, comma, word 2, closing parentheses, and then colon. Okay, then I have a little doc string here. That's always good practice. It's not necessary. This doc string is not not necessary for the function to work, but it's good practice to just summarize what the function does so that you yourself, when you read this thing 2 or 3 months down the road, you can remember what this thing does without having to decipher every last line of code, as well as other people to see what this function does. So I say takes as input 2 strings and returns as output a Boolean value, indicating whether the 2 strings are anagrams of each other, right? Okay. All right, so this line 5 here says it just simply checks if you didn't give to see if the user didn't even give you any anything, like it didn't give you the required 2 strings. So if there's not a word 1, if not word 1, if there's not a word 1, and there's not a word 2, then raise an error, a value error that says you need to give me 2 strings, please try again. That's what that would do. But it'll only run if both strings aren't given. And then line 7 is another kind of data validation step where you're kind of validating the data, making sure the data that the user gave you is correct before you even go into the function, the body of the function, into the meat of the function. Okay, so this says if type word 1 is not equal, this is a Boolean operator that we saw earlier in a previous lesson. This exclamation point equal sign means not equal to. So if the type of word 1 is not equal to string, or the type of word 2 is not equal to string, then raise a type error and say you need to give me strings, please try again. So that was the bonus thing. Those are kind of the bonus part of the practice exercise. If you didn't get that stuff, don't sweat it. Don't worry about it. All right, so now let's jump down to line 9 here. This is where the kind of the meat of the function really happens. So first thing we're gonna do on line 9 is we're gonna lowercase it. So like I mentioned, you have to deal with capitalization. So I'm just gonna push everything to lower. Excuse me, from line on line 9, I push the word 1 to lower. If it's already lower, then it'll just stay lower. Line 10 does the same thing for word 2. And then on line 11, I create a variable that I call word 1 signature, right? There's an underscore there. So WD1 underscore signature, that's the variable name that I decided to give it, equals a sorted version of word 1. So this is going to sort word 1. And then I do the same thing for word 2. So I take word 1, I sort it, I sort the letters, take word 2, sort the letters. And then on line 13, I say if word 1 signature, which is the sorted word 1, is equal to, remind the double equal sign there, 2 equal signs, right? It's a Boolean operator. It means, is this equal to that? So is the signature of word 1 equal to the signature of word 2? If so, return true. If not, on line 15, return false. Okay. So that's it. That is the function there. So the real meat of the function happens between lines 9 and 16 here. And we can make this much more succinct. Okay, but let's give it a try. So here I have, I'm going to try out the function. So once again, up here, I'm only defining the function. From lines 3 down to line 16, I'm simply defining it. I'm not actually using it yet. Down here on lines 20 and 21, I actually use the function. Okay, so I'm going to give it the secure and rescue, which I know should return true. I'm going to give it book and libro, which should return false, right? Because they're not anagrams of each other. So let me run this script, keyboard shortcut to run the script. And let's see. Yep, there it is. True, right? So this first print statement right here after the testing anagram function. All right, line 19, I just say print out to the user that testing anagram function is going to happen right now. Line 20 actually does the first test, returns true. Line 21 returns false, as we thought it would. Okay. So if you'd like to pause the video and take a look at the heart of the function here. Let me see if I can make all of it visible. There we go. From lines 3 to 16. Once again, lines 5 through 9 are data validation stuff. And so if you don't want to do that at the moment, don't worry about that. But lines 9 through 16 is really the heart of the function after the head. Okay, so if you'd like to pause the video, make your end work, go ahead and pause now. I will point out that this really could be shortened quite a bit. Welcome back. I'm just going to point out this could be shortened quite a bit. I'm just going to comment out these lines and just say if word one, a lowercase version of it, and you sort it, we sort all of that. Sorted is equal to a sorted version of word two lowercase. Then do the true if else, then the else false. So if I run this, I think it should run. Oh, I am lacking. Can you see that PyCharm is saying, hey, you're missing something here? You can see that red underscore. It's saying you're missing a colon there. We run the script, make the console viewable. And yeah, it does work that way as well. You got true for rescue and false for book libro. So you basically from lines 9 to 13, I do these line 9 to 12. I do these various steps of making both lowercase and then sorting them, and then on line 13 I compare. But you really could do all that in one line, right? We just say, okay, here's word one, get a lowercase version of it, pass that into sorted, and then compare that to word two. Same thing with word two. So a little bit quicker, less verbose. All right. Okay, if you'd like to pause the video and try that, go ahead. Okay, so that was your anagram script. Here's some other possible functions. I'll just kind of run through these quickly. Whether the letters of a word are in alphabetical order. Okay, so if you want to try that, pause the video for a few minutes and see if you can either change your function that we just created or probably make a new one where you determine whether the letters of a word are in alphabetical order and you return true or false, right? So pause the video if you like to try this one, go ahead. All right, welcome back. Let's take a look at how I would approach that. How I do approach it in the solution file. Let me just go like this. Okay. So I first on line 2 use the keyword def for define. I decide to give it the function name is alphabetical order, separated by underscores. Then my variable, my argument variable that I'll pass in and use, I'm just going to call word colon indentation. All the rest of this is indented, right? I have a doc string here to make it transparent what I'm doing. Takes as input a string and returns as output a Boolean value, indicating whether the characters of the string are in alphabetical order. Okay. And so this is pretty straightforward. Line 6 says, hey, give me a sorted version of the word they receive as input and save it as a variable name. I decided to call it word signature. Line 7 says, now give me a list of the word and compare it to double equal sign, mind the 2 equal signs there, to the sorted version that you just created in line 6 above. If that turns out to be true, then return true. If false, then return false. Okay, so here, let's take a look. The word act has 3 letters, A, C, T, and they are indeed in alphabetical order. A comes before C, C comes before T, so that should return true. Tree is not in alphabetical order, right? The letters of tree, they're in reverse alphabetical order actually, right? T comes after R, which comes after E. Okay, so let's try this. I'm going to run the script, keyword shortcut. And there we go. Testing alphabetical order, which is printed by line 13. Line 14 printed true, which is what we'd expect with act. And line 15 dealing with tree printed false. Okay. So you may be wondering, okay, what exactly does this list word do? Let me just bring up an interactive console real quick, and from window tool view tool windows Python console. Let me just show you real quick what that does. So if I pass in, there's a list function, by the way. List here, open close parentheses, is a function that creates a list. And so if I pass in a string like tree, it returns a list with each character in its own element of that list. Okay. If I do sorted tree, sorted is a function, right, that sorts. It sorts a list, the elements of a list, but excuse me, a string is a collection. So what it does is it breaks up the string into characters, so each character is its own element in that list, and then it sorts it. So both of these return a list, the list function as well as the sorted function. If you call sorted on a string, it'll return a list with each character. So that's what that does. And so you can compare those, and it's simply comparing these lists. Is this list identical to that one? No, that's not the case. But if we did this for act, we do it with act there, okay, sorted, the word act. And yeah, so if we call lists on act, we get this list with 3 elements, A, C, T. And if we call sorted on act, the string act, it returns a list with A, C, T. So those turn out to be identical or the same. So, okay. So that is a real quick, not much to it there, function. The real thing, the new thing here is calling sorted on a string and calling list on a string. So if you'd like to pause the video and take a look at this function, go ahead and do so now. All right, let's try another one. Define a function determining whether the vowels of a word are in alphabetical order. So the vowels, not the whole, not everything, just the vowels. Right here in the first, the one we just looked at, we looked at all letters. Now we just want to see if the vowels are in alphabetical order. Okay, so pause the video and give that a try. Ready, set, pause. All right, welcome back. Let's take a look at how I would go about determining whether the vowels in a word, a string, are in alphabetical order. All right, so here we have a function head, right? DEF, define a function, is vowel alphabetical order. I decided to give it the variable name to use the argument variable word. Nice little doc string here to explain what it does. And here I import RE. And if you remember RE from the regex or regular expression lesson, it has some regular expression functions. We're going to use RE sub here. Okay. So there's several ways to do things here. And I just decided to do it this way. So the first thing I do after importing RE within the function body on line 7 is to replace all the non-vowels with nothing. That is, delete them, right? So I use re.sub to look for this regex, regular expression. You can see the R before the double opening quotes. Then I have a character class within a regex. Square brackets means character class. Don't get confused with Python lists here. This within a regex, square brackets means character class, which means any one of these things. But because I have that caret before the first thing, it means any character that's not one of these things. Anything that's not one of these 5 characters, it will replace with an empty string. That is, it'll delete them. Right, word is the thing that we got passed in that came in when the user called the function. And then the flags here means ignore case on this over here. So these could be uppercase vowels as well. All right, so this deletes non-vowel characters. And this is important. The flags equal re.I is necessary in this function so that re.I isn't considered as the argument to count. So the re sub function has an argument between the string that you want to work on and the flags. So in this case, you actually do have to write flags equal. Okay. Line 8 again takes it gets the list of creates a list of the vowels that remain after getting rid of the non-vowels, and it sorts them. Okay, we're going to call that vowel signature. And we say if a list version of the vowels that you have from line 7 is equal to, two equal signs there, don't miss those two equal signs, is equal to what you just created on line 8, which is a sorted listed version of those up there. The only difference here is that we have sorted on line 8, but we don't sort here. Right, so we're saying if the vowels are in alphabetical order, return true, else return false. So let's take a look here at the down here, line 16 and 17, where we test the function out. Cameron, looks like those vowels are in order, right? The A, E, and the O are in alphabetical order, so that should return true. Juanito, it's not. We have a U, an A, an I, and an O. So the U is the one that is out of order. So this should return false. Let's run the script, see if that happens. Yep, here we go. We're testing vowel in alphabetical order function, and true. So line 16 with Cameron, return true. Line 17 with Juanito, return false. Great. So that works. By the way, I was a Spanish professor for 10 years before coming to BYU. And so I love Spanish. Take a look here at the function if you'd like to make it work on your end. Here it is from lines 2 down to 12 is where you define it. And then lines 16 and 17 where you call it. Once again, you have to do print, call the function, and then pass in some string. Okay, so if you'd like to pause video now, go ahead and do so. All right, let's take a look at another one. Write a function that determines whether a word has all 5 orthographic vowels, like the word sequoia. The word sequoia has all 5 orthographic vowels. It has E, U, I, O, and A. All 5 orthographic vowels are there. So take a minute or a couple minutes or more to see if you can create a function that does that returns true or false on whether a string that you pass in has all 5 orthographic vowels. Ready, set, pause. Okay, welcome back. Let's take a look at how I approach this. There are 2 ways to do it. There's often many ways to do one thing with code. So let me show you one very verbose way of doing this. Okay, so once again, on line 3, I define the function. I start the function definition with the head with the special keyword def. I decided to give it the function name has _ 5 _ vowels, open parentheses. I decided to give the variable name word to the argument that comes in from the user of the function, close parentheses, and then colon. Everything else is indented 1 indentation down to the bottom of the function definition. Okay, so then I say, okay, if lowercase a is in word, good, then do this. And within that true statement, I say, okay, now I know that A is in the word. Now let's tell me if E is in the word. That's what line 5 does. And if that's true, then we come down to line 6. So now we know that E and A are in the word. Now let's see if I is in the word with line 6. If that evaluates to true, then it comes down to line 7. And it says, okay, now I know A, E, and I are all in the word so far. How about O? Line 7 says, if O is in the word, if that's true, then jump down to line 8 and look at U. So now we know all 5. Well, we know that 4 of the 5 are now in the word. And we say, okay, if U is in the word, then jump down to this, which says return true. Okay. But if U is not in the word, but all but the other 4 vowels are, then jump down to 10 and do line 11, which says return false. And okay, and then we kind of work our way out of this, these nested if statements. Okay, so this else on line 10 corresponds to this if on line 8, right? Because they're lined up on the same level of indentation. Line 8 is indented the same amount of indentation space as line 10. This is one statement right there. Okay, so this if is indented right there, and this else is at the same level of indentation. So this else statement corresponds to this on line 12, corresponds to the if statement on line 7. Right, so if there had not been an O in the word, it would have jumped down to line 12 and then run 13. Same thing with the other else statements here. They correspond to their if statements that have the same level of indentation. So the else statement on 14 corresponds to the if statement on 6. The else statement on 16 corresponds to the if statement on 5. And the else statement on 18 corresponds to the if statement on 4. Right, so there's only one true in here. There's only one way that we can get to return true, and that's if all of these evaluate to true. That is, we have all 5 orthographic letters. If that is the case, then we return true. If that's not the case, then everything else is going to return false. Whether we have 4 of the 5, but not 5, it'll return false. Or anyway, it goes in order. It says, if you don't have an A, then return false. Okay, if you do have an A, now check for an E. If you have that also, anyway, it goes from A down to U. That's one way to do it. We can test this. So Sequoia should return true, but University should return false. I'm going to run the script with the keyboard shortcut. Let me make the console viewable here. Test 5 vowels function. So true with Sequoia, yep, and false with University. That's correct. We've got quite a few vowels in here, but we don't have all 5. Okay, so that works. If you'd like to take a minute to look at this, it's pretty pretty nested here. It's kind of hard to follow this nesting structure. And if I were writing this, I would go like this. I would say if A in word do something else, return false, and then come up into here and say, okay, now I know A is in there. If E is in word, do something here, else return false. Now come back up here and say, okay, now I know that both of those are in there. And then if I is in this word as well, do something here, otherwise return false. This is the way I wrote it. This is the way I would write it. I would create the else statement right when you're writing the if. Right after you write the if, do the else and return false. And then come back up into the true statement and then flesh out the code a bit there. That's the way I'd recommend writing that. I think that's the way I wrote it. Okay. So I'd like to pause the video, take a look at that in the solution file. Do so now. Okay. There is another much less verbose way of doing this. Let me grab that. Pull up here. So I'm going to replace this function definition with a less verbose way. And it uses the and operator here. Okay. So once again, here on line 4, we have the function definition head. And on lines 5 through 8, we have the function body. And so we say if A is in word and E is in word and I is in word and O is in the word and, you guessed it, U is in the word, then we have, if all of those evaluate to true, then we know we have all 5 vowels in the word and we say return true. If this evaluates to false because one or more of those 5 vowels is not present, then we jump down to else and we run return false. So this does the same thing as the previous code, but much less verbosely. Verbose meaning less computer code, but it has the same effect. True, because Sequoia has all 5 orthographic vowels. False, because University does not have all 5 orthographic vowels. This is a much cleaner way, much less verbose. Excuse me. And we're using the AND operator here 4 times. So if any one of these evaluates to false, it would cause all of it to evaluate to false, and it would jump down to the else and then run return false. Okay, if you'd like to pause video and look at that, go ahead. All right, one last little practice exercise. It says, write a function, determine whether a shorter word appears in a longer word in the same order. Like, for example, out is in counter, right? Because we have O-U-T in the word counter in that order. O-U, and then we have an N, and then T. So see if you can do that. Take a couple minutes here or more and struggle to get this done. The learning happens with the struggling. To figure it out, try, experiment, try this, that doesn't work. Okay, what do I do? Google, Python, ideas you have about how to do this. Ready, set, pause. Okay, let's take a look at how we could accomplish this little task. All right, let's come over here. Let's talk through this a bit. Once again, we have the good old-fashioned function head with the def keyword. We have 2 arguments that get passed in by the user, one short, one long, right? So we're gonna control for capitalization by pushing everything to lower, pushing both of those things to lower with lines 3 and 4. Then we're going to create an empty list that we call indexes. I'm going to call it indexes here. And this is shorthand for a longer thing of indexes equals list, open close parentheses. This has the same effect. So you can create an empty list by giving a variable name, a well-formed variable name, assignment operator, equal sign, and then open close parentheses, square brackets. That's shorthand for a more verbose way of doing it with the list function, which has parentheses. Okay, then we're going to loop over each letter of the short word, right? So I'm going to give it the variable name letter here on line 6 in short, which is the name of the variable that holds the short word. We're going to look at each letter, okay? And then what we're going to do is we're going to try, which I haven't shown you try except yet, have I? This one may be a little more advanced, and if you can't figure this out, then don't sweat it. I haven't shown you try except yet, but this means try to do this line. If that fails, then come down and do this line. But here we go. So we're gonna look at long, and we're gonna find the index of letter, meaning the current letter in the short word. So this dot index is a string function that tells you where in the string this letter occurs. But if that throws an error because it doesn't occur, then this try block would say, jump down here, there's an error, and return false. Meaning return false out of the function because we don't even have the current letter in short. That current letter in short is not even in the long word. But if we do find it, then push on to the index, excuse me, the list that is called indexes, push onto it the current index. This is shorthand, so that plus equal sign is shorthand for indexes dot append current index. Okay. And I think this is a little bit more transparent. I'm just gonna do this one. Okay. So this means take your current list called indexes and append onto it the current index of the letter. The current letter in short, where is it in long? Put it onto this collector list. Okay, once we've gone through all the letters of short, right? So line 6 is at the same level of indentation as line 13, right? So that means the for loop that starts on 6 will complete running. It'll go through all the letters in short. And once that's done, it'll come down here and say, okay, if a sorted version of indexes is equal to itself, meaning indexes, meaning you take whatever order they were put in, and you compare it to a sorted version of itself. And if that's the same, then return true. Otherwise, if they're not the same, then return false. Okay. So for example, with counter and out and counter, this should return true because the O is at index 2, no, index 1, that is the second letter, but index 1. Remember that Python is a zero-based indexing language. And the U is at index of 2, the third character, but the second index. And the T is at index of 4. Yeah. So 1, 2, 4, if I sort those, I'm going to get 1, 2, 4, right? So that should return true. But here, it's going to return false because the first thing is there's no U in university. So it's going to actually run this line on 10. It's going to say, I don't even find the first letter in the longer word. So I'm going to return false right now. Not even do anything else. All right, so let's run this. And yep, we got true for out and counter, but we got false for university, out and university. All right. So let me just try another one real quick to show you. Let me do, I don't know, A, B, C, and some string. I can't think of an actual word right now, so I'm just going to do silly stuff. I got an A, that's in order. Then I got a C and then a B. So I do have these 3 letters in this string. I have an A. I'm looking at these 3 letters right here, right? A, B, C. Those are in the longer string. There's A, there's B, and there's C. But this should return false because the B and C are not in order, right? The index, they're out of order. So let's run this, test my hypothesis. Yeah, the third thing here, we have true for out counter, false for out university, and false for ABC and ASDF CB. All right, so if you'd like to stop the video and look at this code, it's a little more in depth. If this is out of your wheelhouse, if this is just confusing, just don't worry about it, just move on. But take a look at the code if you like for a few minutes. So. Okay, so we've seen with functions how to define your own function, which are called user-defined functions because the user defines a function and uses it in their script, right? So you should be able to do that now. Give it a try, keep working with it, make sure you feel comfortable defining your own function. Okay, and I'm gonna comment that out real quick. All right, well, that is lesson 4.1. Hope you enjoyed it. We'll see you next time.